Recording in progress.
Thank you. All right, what you say?
Got a strong voice.
Yeah, I grabbed that somewhere.
You just grab it from anywhere, just hold that down and drag it.
You want to throw it down?
Okay. This one covers 44 questions, and there'll be 4 exam questions out of this, 4 groups. And it basically is going to talk about in a lower level what we did in the basic electronics. Talked about, you were in that one, oscillators and mixers and so forth, and radios, transceivers. So it's kind of a higher level. Basically, a transceiver is just a combination of a transmitter and a receiver in the same package, sharing the same antenna.
Can we stop using the praying for?
A transverter.
Converter.
Is a device that can convert HF to UHF, VHF. Conceivably, it could go the other direction to MF or LF, I suppose. I'm not sure. Maybe it only has to do harmonics. I've never seen one. Have you used transverter?
The transformer, I use them all
You do? Yeah.
the TV. Yeah,
Okay.
does it all for me. I have to solve it.
But the bottom line is it converts signals to VHF, UHF. And guess what? There's a question. What is the transceiver? What device converts RF input output of a transceiver to another band?
Charlie.
Cheever. I like that. It's close to cheever.
Typical transceivers, but there are exceptions. Normally, a handheld is going to be 5 watts. Some advertise as much as 8. Not sure really have 8. Doesn't make that much difference. It's less than 3 dB. Most mobiles are 50 watts. Most base stations are typically 100 watts. The expensive one we talked about is 200 watts. So you get an extra 100 watts for an extra $10,000. It's got some other things.
Yeah. Was it legal?
Huh?
Is it legal to run 2,000 watt?
Not in the amateur band.
Are you sure?
Pretty sure.
Where's the power measured at?
They write 1,500 watts PEP
Measured where?
at the output of the transmitter.
At the transmitter now instead of the amp?
Believe. It's the input of the antenna.
At the end. So if you've got 200 run. Yeah. Or if you're running sideband.
If you've got 200 feet of coax feed line, okay, that doesn't help you and it doesn't count because you're measuring at the input of the feed line.
Not then the feed line, but then of the end.
No, the output of the transmitter, including power amplifier, and is PEP, peak effective power, not effective radiating. That's different.
Yeah, the effective radiating power is taken gain of the antenna.
Yes, it does. That's the difference.
Yeah.
ERP is
Yeah.
gain and everything in
Yeah.
the link.
So the legal limit of 1,500 watts does not take in the DR,
Right.
but, in.
And it's peak effective power, so when you look at the envelope, it's peak in the envelope. So if you've got a voice, you know, it's up and down, it's highest.
Yeah.
Peak to peak.
So highest peak, but, I didn't realize they changed it to the amplifier and said, input at the end.
I'm pretty sure it's at the input to the feed line and where they define it. We might get to that, or we've already done it. I don't remember.
So, have you ever heard of the FCC coming to audit it? Yeah, did it?
They just find somebody $25,000 interfering.
Yeah.
You generally have to be obnoxious for the map deal.
Have people report you.
Yeah.
Many times.
They theoretically, I mean, they can just say, I'm coming by.
Mhm.
But as far as I know, that doesn't happen. They usually have to have some reason to go travel.
Right.
Where's the closest field office?
I have no idea, and I hope I never find out.
Oh, I assume there was one in this area. Okay,
They'll just send some armed IRS agents in with them.
you can use a power amplifier or linear amplifier, depending on what mode you're in, to increase your power up to the legal limit, which is 1,500 on the upper bands. Some of the lower bands, it's 200. And on the new, what is that super low one?
It's not the 70 center.
No. The other way. It's lower than 1,200, whatever. I think it's limited to like 1 watt.
On the part.
Might be. It's fairly.
2,200 meters.
Okay.
1 watt.
Some power amplifiers have a mode switch so that it will set its output depending on what operating mode you're in, whether you're doing single sideband or CW, or whatever, it will automatically change it for that mode because your power limit is going to be different.
All right, it is transmitter power. It's no longer measured at the antenna, correct?
51% of the time.
Yeah.
You can be a weatherman.
I'm glad someone keeps up with the rules. Of course, I've never owned an amplifier, so.
Yeah, me either. But I've taught this course 3 times now. So I remember some of them. What device increases the transmitted power output from a transmitter?
Bravo impedance step.
Oh, yeah. Helps.
Move up higher.
What's the function of the SSB CW FM switch on a VHF power amplifier?
Yeah, it changes.
Gets
Bravo. Here's, we'll read them all.
All right. Set the amplifier to the operating and select.
Yeah.
There.
It doesn't change the mode of the signal.
Yeah.
It changes the mode of the amp.
That's cool.
Tricky. 2 of the most important specifications are sensitivity and selectivity. Sensitivity is defined as the ability to detect a signal. There's also a definition of the minimum power level received, I should say, at which the receiver can clearly receive a signal. And sometimes they include RF preamplifiers in the radio. Sometimes it could be external, which can improve the sensitivity. It probably impacts the selectivity. It's one of those, you can't have both. Selectivity is the ability to discriminate between two or more signals. So you've got signal you're trying to listen to, and you may have some fairly adjacent signals, could even be stronger, and that's the worst case. So how good of selectivity do you have in the front end in the IF section will determine whether or not you can narrow it down to just that selected signal and not hear the other ones.
So the RF preamplifier is unidirectional. It'll only work for receiving. So
Yes.
when you go and transmit it on, it'll turn off automatically.
There's in a transceiver, you've got a transmit receive switch.
Mhm.
Whenever you do push to talk
Right.
or Vox, it does the same thing. And most of them it's a relay. Okay, and it will switch the receiver portion out from disconnected from the antenna and connect the transmit.
Right, but I'm saying if the RF preamplifier is external.
Oh, then you need to have an external transmit receive switch.
Okay. To
I had to take it out because it started acting funky. One of these noise reduction eliminator boxes on the front end, which had a TR switch in it, and you had to hook it up so it would switch it out. You know, it lets you play with the phase and a separate antenna so you could do like diversity and cancel noise out. It kind of worked until it stopped working.
I was using the two-way radios when I was dispatching at the taxi company, foot pedal, transmit receive switch to be used.
Okay, what term describes the ability of a receiver to detect the presence of a signal?
Problem?
We're sensitive to that.
What term describes the ability of a receiver to discriminate between multiple signals?
Like,
Where is an RF preamplifier installed?
Secret.
There'd be a receiver.
Okay, AM receivers. This is one of the early attempts to gain both sensitivity and selectivity, called a tuned RF frequency receiver, where they had a gang RF preamplifiers or amplifiers on the front end. Made it mechanically, you know, with old tuning capacitors, they all had to be ganged together. You had to worry about crosstalk between them and stuff. But it worked. Then came the super heterodyne, where they introduced a mixer right after the front end RF amplifier to convert the signal down to a lower intermediate frequency, where it was easier to filter it and amplify it. And that's kind of even today, except for SGR radios, most of them are heterodynes, super heterodynes, or hybrids. In fact, most of the super heterodynes that I've seen, actually, the higher end ones, would use two mixers and two different IF frequencies. And then we have the newer direct conversion or software defined radios, where in a completely software defined radio, basically inputting your RF signal into some analog to digital conversion, which is usually part of an integrated circuit. And they're processed, filtered, everything you would do in a regular radio, all done digitally in software firmware, essentially. And output an analog signal that then goes to your normal audio amplifier, headset, or speakers. There are some that still do mixing in front of the process. So basically, the IF portion and the audio portion done gets.
Do you have a higher latency with these setups? With the processing time, or is it that fast?
Yeah, it definitely delays the signal, but you're not relative to anything.
Right.
So you don't know it. I mean, even in analog circuits, it's delayed, just not as much.
Right.
Okay, so basically the differences on the superhet, we're using a mixer. And we're talking about those four. That allows you to convert the RF signal to an intermediate frequency signal. So in the ideal mixer, okay, you're going to get the sum and difference of the two frequencies. So the difference in frequency between the local oscillator, which is typically what they call the oscillator in the receiver that you tune it with, compared to the RF signal you're trying to receive, that difference in frequency is going to be IF frequency. You'll have two. One that's above the carrier frequency, one that's below the carrier frequency.
So it's two side bits.
Well, kind of, but you're not doing the baseband part of it yet. So it allows you to just use the one for the IF frequency that IF filters are set up for. And the other one will be way out of band, so you won't see it. Which of the following is used to convert a signal from one frequency to another?
Mixer.
Bravo.
Okay. Now they have a local oscillator that is how you tune to a particular frequency by whatever that offset difference in the IF frequency offset. And the local oscillator in some cases could be a higher frequency than you're trying to detect or lower. Usually it's lower. This is just a typical example of a what's that? Not coal pits. The other one.
My mind was just somewhere else.
Anyway, it's one of the basic configurations for an oscillator. And all it is a tune circuit, an amplifier that can provide one-to-one gain while it's oscillating. In other words, it has to overcome the loss in the circuit to maintain oscillation. The trick is it's got to have higher than one-to-one gain to start it oscillating. So you have to have it set up so there's a variable gain in this, makes them harder than you think to make them oscillate. What is the name of the circuit that generates a signal at a specific frequency?
Delta.
Sliding.
Okay. Oh, now in most of the newer radios, a lot of times that local oscillator is not going to be done with an analog circuit. It'll digitally generate. So AM/FM transmitters use a modulator circuit. In the case of FM, it's going to be a reactance modulator to vary the frequency, where in AM, it's just going to be an amplitude modulator. And that's how you combine the speech or analog voice signal or in a digital signal with the carrier, right, to perform modulation. The transmitter is kind of the reciprocal of the receiver. You have the local oscillator to make the difference. You have a carrier oscillator, which is your signal, and then you're going to modulate it, okay, to get the signal at different frequency with side bands. And this is just showing, if you can see, the negative portion of the input signal is giving you a lower frequency, and the higher amplitude is giving you a higher FM. It's changing the amplitude of the signal on the AM. So in theory, the FM signal doesn't care about changes in amplitude. In practice, the FM discriminators do, so they'll have a circuit called a limiter, which basically is like an automatic level control that will maintain the amplitude going to the discriminator, so there's no amplitude artifacts.
The emphasis and de-emphasis circuits use wideband broadcast.
It has to do,
The base,
you do emphasis or pre-emphasis at the transmitter. And I can't remember now, but it makes it a little more efficient in actually receiving the signal, and then you do the de-emphasis circuit to I think it's kind of like compression on SSB, but I don't remember for sure.
and it's more like
Yeah. I think it's sort of frequency domain equivalent.
yeah.
Here's just showing the message signal coming in to the modulator and carrier. So your modulated signal is going to be basically, again, the sum and difference of the two. And depending on that modulator, you could have a carrier or not have a carrier. If that was a balanced modulator, or double, triple balanced modulator, the carrier frequency will be absent. See sidebands. Which of the following describes combining speech with an RF carrier signal? Charlie?
They're not.
Really cracking yourself up during the exam, remembering it this way. He's gonna be in the corner there chuckling while he's sitting there penciling
I'm
it
telling you, phonics help.
in.
Anything that helps. Idea is to pass the test and then really learn the stuff later. Like use.
Well, that's the deal. We're picking up 1 to 5% of what's needed here. The rest of the information we got to learn.
It's your learner's permit.
You know,
Okay. RFI can be caused by fundamental overload, harmonics, or spurious emissions. And any of these can cause problems with TVs, radios, computers, in most kind of electronic device. Fundamental overload is when you have a very strong signal that is close enough in frequency that it's actually exceeding the input signal level of your RF amplifier or the front end of your radio, because they have a certain dynamic range and they'll only go up to so many microvolts or millivolts of input. So if you got a signal that's greater than that, it's just going to saturate it, and you really won't hear much. You can have harmonics, which are multiples of a lower frequency, and it just happens to be within your passband. And you can have spurious emissions where there's frequency spurs that are being generated because somebody's got a transmitter that doesn't comply with the FCC rules on, I forgot now, what is it, like 50 or 60 dB down for
Say, six,
something like that for the second or third.
yeah,
The Bang Fu, first one, the 5, the initial ones put out a lot of spurs. I don't think they actually complied with the FCC. So most of the clones of the Bang Fus have supposedly fixed that problem. Which of the following can cause RFI?
Delta.
Okay, if RFI is affecting a nearby radio, TV, or yours or your neighbors, the first thing you're supposed to do is ensure that your equipment is operating properly. Make sure that all your connectors tight, installed properly. Crimps on the shield and stuff are good, or if it's soldered. And then verify that your own radio and TV and computers aren't being affected when you transmit. So if you do all that, then the problem is usually on the other person's end where they've got a crappy radio. No. Which of the following actions should you take if a neighbor tells you that your station's transmissions are interfering with their radio or TV reception?
I like
You do?
double harmonics. I'll pick.
You want to see Alpha? Okay. Yeah. Put power to their house.
There you go. Of
There, your problem just went away.
course, now if you turn your transmitter off, it would solve the problem.
Well, if you turn the receiver,
That would solve the problem good.
Or you do something silly like,
What should be the first step to resolve non-fiber cable TV interference caused by your amateur radio transmission? I think they're assuming here that you're not going to be able to cause interference with the fiber optic.
Delta 5.
Fundamental overload. When you got an extremely strong signal on a nearby frequency, and even if it meets the criteria of having this skirts 50, 60 dB down, if it's a high enough signal, okay, you're still got to get enough, could get enough power out of that profile that it's going to overload your radio. If it's close enough, it's 10 times the signal.
that's a little button in the ear for the wife of the hearing thing.
Low selectivity of the receiver, like a cheap radio, okay, can cause it. And you can block the signal by putting an input filter, okay, to block that particular frequency, like a notch filter, or maybe a low pass or high pass, depending on whether it's above or below you.
Next time Sharon says I'm not listening to her, I'm going to tell her it's low selectivity of the receiver.
What would cause a broadcast AM or FM radio to receive an amateur radio transmission unintentionally?
Yes.
Can fundamental overload of a non-amateur radio TV receiver by an amateur transmitter be reduced or eliminated? B would be kind of hard because that's your signal. Might as well turn it off.
So you start doing QRP, anything wrong with that?
Okay. FM broadcast station interference. Overload of a mobile VHF radio. If you're located too close to an FM broadcast, which is like the only example, and install a band reject filter to possibly fix it. Probably best to move unless it's your house. Then why did you buy it if you were a hand
What do they define as too close?
where it's causing interference?
Okay.
They don't. I know, back, it's probably still true when I was growing up, some of the local radio stations over in Cincinnati that put out 100,000 watts, and people that lived around there, their electric lights were
Everything hung.
low.
And my brother attended Baptist in Marietta for a while. And, you could hear the local AM station through the, fire exit signs.
Good one. Messed up WKRP.
It's WKRC actually. Which of the following can reduce overload of a VHF receiver by a nearby commercial FM station?
Delta.
Yeah, don't. Dog. Dog.
What if neighbor's equipment interferes with yours? Move. Huh? Move. Or chase them out? You're supposed to work with them to find the cause of the interference. They list this second, but I think it should be down on the list. You're supposed to politely inform them of the FCC rules. Might go big.
They're usually.
Make sure that your station meets the standards of good amateur practice, which you probably should do first.
What's wrong with attending the coax?
Yeah. And then try to help them fix the problem.
Yeah.
So what should you do if something in your neighbor's home is causing harmful interference to your amateur station?
All the above.
That's in theory.
Yeah, I've got.
Depends on if you like your neighbor.
If you're not friends with your neighbor, it's probably not gonna work. Common transmitter receiver problems: distorted, noisy, or garbled audio on FM. Can be caused by off frequency, so you can adjust the tuning. Low batteries, talking handy talkies. You're in a bad location. You could be getting multipath or just blocking of the signal where it's very low. You could be getting RF feedback because you don't have good grounding and shielding. There might be common mode coming back on the feed line. You could be over deviating where you're holding the microphone way too close. So you've got more than 100% modulation, which causes stuff to happen.
Is that what means calls me? Yeah.
Yeah. Did they call you over deviant or just a deviant?
It's a little bit more than your microphone being too close.
What might be a problem if you receive a report that your audio signal through an FM repeater is distorted or unintelligible?
Oh.
What is the symptom of RF feedback in a transmitter or transceiver?
See. Yeah, I think. I wish it was give to once.
Yeah, I've heard about RF burns. I haven't had one. Do they hurt?
I'm not, not a long time.
Oh, okay.
But you have done it.
Garbled, distorted, unintelligible. What can you do if you're told your FM handheld or mobile is over deviating? I was told that once, the first time I got on a repeater.
You were talking too close to the microphone.
I didn't. Actually, you're supposed to kind of hold it sideways, talk across it. Not directly in.
The CB, we used to have a microphone hang truck and reach up and talk.
Okay, test equipment. A multimeter's the most common piece of test equipment. You almost have to have one. It's called a multimeter because it typically combines a voltmeter, an ohmmeter, an ammeter. It may have capacitance meter, it may have a transistor checker, it may have a temperature sensor, and several other things.
They don't spend that much money.
Even the cheap ones have more than the three.
And if you have a $12 Amazon version,
The free ones that
Harbor Freight?
Harbor Freight, you get
Yeah, it's got a,
meters.
yeah,
And the price is great.
right.
You,
You've got several of the little yellow ones.
I had to rent.
Oh.
you just gotta remember to replace the 9-volt every 2 or 3 years.
Mm-hmm.
Look at some of the videos of people putting, overload condos. And the cheaper ones, when they fail, may not necessarily fail in a safe.
Oh, really?
Yeah.
How would they fail in an unsafe manner?
You might end up with a, where you could have one, where you could have, either a fire or like.
Okay, so a short when you're measuring 240 volts wouldn't be good.
Yeah, probably not.
Okay. Obviously, the voltmeter setting measures volts. The ohmmeter setting measures resistance in ohms, and the ammeter will measure current in amps. Usually they're milliamps. Most of the cheaper ones will only go up to maybe 5 or 10 amps, and they usually have a separate jack for the amp meter part as opposed to milliamps. One of the biggest mistakes is to measure voltage when you're on resistance setting. A lot of them don't recover.
The amps or an amp too.
Sounds like a voice of experience.
Here's some typical higher end ones. The analog one over here was sort of the classic. I don't know much about their new digital version of it. I suspect it's pretty good. I'm guessing that it probably costs a few $100, like a flute. Which of the following measurements are made using a multimeter?
Certainly.
See. Which of the following can damage a multimeter?
Charlie.
See.
Yeah, they'll get pretty good.
Okay, voltmeters. They measure potential across a component. There's usually low to high voltage settings. Most of them, like in a multimeter, will go up to maybe 600 volts. Can be an analog or digital. They will display in volts typically. I have a few that go down into the microvolt range. They appear to have a very high resistance when they're in parallel, so they don't take much current out of the circuit. So they don't affect the reading very much. Unless you're reading voltage across a very high impedance circuit, and then it's gonna affect it a little bit more. And you need to ensure that it's rated for the voltage you're trying to measure. So if it's 600 volts max and you're trying to measure an old, 2 transmitter and you got, 1200 volts or something on the plates, it's probably going to be a one-shot deal.
On the smoke test.
Which instrument would you use to measure electric potential? How is the voltmeter connected to a component to measure applied voltage? Which of the following precautions should be taken when measuring high voltages with a voltmeter? Usually one of the limits is the test leads themselves. Well, the insulation is rated maybe more than 600 volts. Okay, an ohm meter measures resistance by supplying a known current to the circuit. So it's actually a voltmeter, the little current source. And it measures the voltage drop across that and converts it either with an analog scale or in the digital one to resistance by effectively doing Ohm's law mechanically or electrically. Can have an analog or a digital display. They will display in units of ohms. If you're reading a circuit with a large capacitor in it and it's discharged, you're going to see a extremely low resistance reading, and it will gradually climb up to an open circuit reading. If you're doing a large inductor in the circuit, then you're going to see a high impedance or resistance initially, and it will drop down to close to zero, depending on how much resistance is in the coil. In case of an inductor, unless it's a very, very large inductor, it's going to happen so quick you won't see it. It'll kind of be a blip. Let's see. What's it say down here? Ensure the circuit being measured is not powered.
That's
How is an ohm meter connected to a component to measure its resistance?
Okay. Sure. Yeah, it's just, yeah.
Yeah, ohm meter.
Yeah, but actually,
Right, terrible. You don't take it out of the circuit. Measure across it. You're fusing it with the one coming up.
your meters in.
What reading indicates that an ohm meter is connected across a large discharge capacitor? What'd you say?
up to K.
Yeah. Okay, be increasing.
B would be the inductor.
Where's a discharge capacitor is going to appear at zero resistance because you've got to charge it up. And as you charge it, it the current goes down because the difference in potential. When it gets up to whatever your charging voltage is, then there's no current flow, which is equivalent to infinite resistance.
Actually, thinking the capacitor discharge. You know, yeah.
Okay. Ammeters. They measure current in a circuit. Must be inserted in series in the circuit. Analog or digital displays, they display in units of amperes. And you need to make sure that it's rated for the current you're trying to measure. Particularly, well, I'd say most of them have a separate input for higher current measurement than the normal one. So you need to make sure that if you're reading 10 or 20 amps, that you're plugged in, your test lead is plugged into the right.
So you gotta have the same cord, it's just a different setting of dial.
The non-contact in for being measuring magnetic.
Yes. The AC ones.
Yeah.
Usually.
I think there's a way to measure DC current with a loop type thing, but
Yeah.
I'm not sure.
Because I remember.
I think it's like a Hall effect or something. Normally, you're just doing AC.
Yeah, cords. You get them on cords.
Yeah.
You get better accuracy. You make 2 or 3, 4 loops through it and just divide your reading by.
Yeah. What instrument is used to measure electric current?
Delta.
Configured to measure current, how is a multimeter connected to a component?
Alpha.
Soldering, an essential skill. I want to build things. Some people have no interest. They just want to talk on the radio. They recommend rosin core solder for doing all of the electronic connections between components, wires, as opposed to acid core, which is specifically used for essentially plumbing connections. The problem with, as I understand, with acid core is unless you can really get rid of all that flux, that acid is going to circuit board cause problems with the copper. The idea is to heat up the components, both in the case of a circuit board, the component and the pad on the circuit board that you're trying to connect to simultaneously. So you got to get the soldering iron in where you're making contact with both of them and heat it up to the point where it will melt the solder and not melt the solder on the tip of the solder. If you've got a good joint, it'll be really nice, bright, shiny, smooth. If it's a bad joint, you can pretty much tell it's not going to be very shiny. It's going to have a grainy, dull appearance. Huh? Yeah, and it may, if you actually measure it, it may be a very high resistance, even an open circuit. Even though it may mechanically be enough to hold it in place.
I mean, I think a common issue is people dab solder on the end of the soldering gun and just trip it on there without heating the component up. It just sits on top of it.
Right. Now, in those cases, you can go back, put a little flux on it, and reheat it, fix it. Which of the following types of solder should not be used for radio and electronic applications?
Not passive.
What's the characteristic appearance of a cold tin lead solder?
Let's see.
Hey. Any questions about all that stuff?
So, where are we finding good solder?
Our test.
Yeah.
I've got a couple rolls that supposedly is good solder, but it's not a name brand.
I used to get it at Radio Shack, but I don't think you can find them anymore.
Might as well throw it in the trash. It will not make a connection.
But I know they have the new, lead-free, type solder, iron chip. Different plus.
Well, some of the stuff I got is 6337, and it still doesn't want to melt. And run it up like 450 degrees.
Yeah, 60, 40 was.
Yeah, but 37 63 melts at lower temperature. It's the binary you take for tin and lead. One thing I learned in thermodynamics. Well, two things: how to make
Coffee.
how to make freezer brandy.
Freezer brand.
Okay. Take wine and you freeze it until ice crystals form. Filter out the ice crystal. So you've removed the water.
It's the opposite of what they teach you in prison. Just mix the stuff, stick it under the stairwell for a week.
So
Yeah, but not many prisoners have access to a good freezer.
Yeah.
Good trust.